When floodwaters swallow the doors of a modern electric vehicle, the immediate aftermath looks deceivingly calm. The exterior remains pristine, and the cabin might even be completely dry. Submersion initiates a silent chemical chain reaction inside the battery pack, often reaching a critical state hours or days after the water has receded. Industry standards like IP67 or IP68 ratings suggest a battery pack is immune to water damage, but these certifications have limits in the field. Those ratings are earned in laboratories using clean, still water. Real-world floods carry a dense mixture of heavy mud, agricultural chemicals, and road salts. This contamination transforms ordinary water into a highly conductive electrolytic fluid. Standard factory seals often fail against prolonged contaminated submersion, leading to a delayed thermal event that incinerates the chassis. The battery enclosure relies on mechanical breather valves designed to equalize air pressure during normal driving, but they are not rated for prolonged submersion. The weight of standing deep water creates sustained hydrostatic pressure, which eventually forces contaminated liquid past these breather valves and directly into the pack. Once inside, this conductive fluid pools across the internal modules, bridging electrical gaps that must remain completely insulated. The vehicle's battery management system, or BMS, constantly monitors the electrical resistance between these high-voltage components and the metal chassis. As the physical seals fail, the vehicle's high-voltage architecture becomes a compromised electrical grid, triggering internal alarms. When the conductive floodwater touches live terminals, the internal electrical resistance drops towards zero. The BMS detects this drop and triggers an isolation fault, automatically opening the main contactors to sever the high-voltage system from the rest of the car. In a case study involving a submerged Tesla Model Y, this failure state manifested as erratic exterior lights, a sewage odor, and a complete high-voltage lockout. While the lockout stops power from moving to the motors, the thousands of individual lithium-ion cells inside the pack still hold a massive electrical charge. The isolation fault traps this lethal electrical energy inside a sealed metal box, now filled with conductive fluid. With the power trapped and the conductive floodwater bridging the battery terminals, an uncontrolled circuit forms. This electrical bridge initiates continuous electrolysis, actively splitting the water molecules within the enclosure. This chemical reaction produces a highly volatile byproduct, hydrogen gas. Because the battery pack is sealed, the hydrogen bubbles up from the contaminated fluid and pools in a dense layer at the highest points beneath the enclosure lid. A microscopic spark, caused by a lingering voltage spike or shift in debris as the car dries out, can ignite this concentrated pocket of hydrogen. Ignition fractures the individual battery cells, sending them into rapid thermal runaway. By manufacturing its own explosive atmosphere inside the pack, the battery becomes a time bomb capable of detonating well after the flood has passed. Attempting to power the vehicle on is the most dangerous action a responder can take, as it risks sending a high-voltage pulse through a compromised system. The mandatory first mechanical intervention is disconnecting the 12-volt battery terminal. Killing the low-voltage computers prevents the high-voltage contactors from closing, which keeps the main power source isolated. Without low-voltage power, the vehicle cannot be shifted into neutral. Recovery teams must use wheel skates or a dolly to lift and move the tires onto a tow truck. True disarmament requires completely severing the low-voltage computer from the high-voltage power source before the vehicle is moved. Repair facilities must place flooded EVs in a strict quarantine zone, at least 15 meters away from any structures or other vehicles. Technicians monitor the vehicle with thermal cameras for a minimum of 48 hours. A rising hotspot is an early warning sign of cell failure. If stable, they use a Megger insulation tester to measure the exact resistance between the battery and the chassis. Vehicles that pass these tests require rigorous deep cleaning to remove microscopic salts, including the replacement of hidden desiccant packs that have absorbed contaminated moisture. Technicians pull data logs from the BMS to forensically reconstruct the exact timeline of the breach and the system's reaction. Saltwater ingress usually leads to aggressive corrosion that makes recovery impossible, necessitating a total loss designation for the battery pack. Flood recovery requires a forensic diagnostic process to determine if the machine is salvageable or if it remains an active, volatile device.